everyone. In this video we are going to discuss about boring billion, which is not so boring. Actually, in geological past there are certain period when actually it is not so called inactive earth, but little bit lesser amount of dynamicity is observed, and even it was not so eventful. So a particular time when earth achieve its mature age, huh? For example, earth age is 4.6 billion years, okay, and active earth's main earth stability, earth got stability by 3.8 billion years. So at the middle age, as per like the human being, earth have also got middle age crisis. So by you can make half of 3.8, that means 1.9. So approximately from 1.8 billion years to 0.8 billion years, that time period, directly 1 billion year was not so much eventful. So that period is called boring billion, but it is very much significant because, as you know, most of the Proterozoic basins, Proterozoic rift basins has been formed in this time. And boring billion, as I have told, it was not actually boring. From paleontological point of view, this terminology was coined by Brazier, one cultivate paleontology. So he noticed that there was no that much biological activity or much evolution happened. So that term was coined by him, but tectonically and from biogeochemically, it is significant. The boring billion years, that is Mesoproterozoic, mid Proterozoic. Okay, that time what happened? Actually, immediately after great oxidation event. Great oxygenation, as we know, it is around 2.2 billion years. So after just 400 million years of great oxidation event, that is when Earth become 1.8 billion years from today, that time sudden changes happen. Okay, so it persists up to 1 billion years. Although it is bordered by two different oxygenation events, that is, as I have mentioned, great oxygenation and neoproterozoic oxygenation. So it is bracketed in between these two great oxygenation, and two global glacial events also bracketed, that is Huronian and Cryogenian. These two glacial events are also bracketing this boring billion. The boring billion period itself actually had very low oxygen level and no geological evidence of glaciation. So if we subdivide the Earth's entire history, major phenomena, we can see at the beginning that oxygenation events, before oxygenation events, it was totally chemically inactive earth, okay, but after oxidation, great oxygenation event around 2.2, or sometimes somewhere at places, because earth is not uniform, at places it started 2.4 billion years, at places it started 2.2, at places even 2, so it ranges. So overall, during these oxygenation events, iron rich ocean was prevailing. So that time banded iron formation has been formed. Now then, from 1.8 to 0.8 billion years, that time oxygen suddenly got reduced, okay, and sulfur come into existence. Most of the ocean water was reached in sulfidic ocean. This is called euxenia. Euxenia means oxygen is limited and sulfides are more, because that time sulfate reducing bacteria is prevailing, and those bacteria, what they did actually, for example, when photosynthesis happen, what that bacteria do? Photosynthetic bacteria take water in sunlight and carbon dioxide, they prepare glucose and release oxygen. So water means H2O. So instead of H2O, if it is using H2S, hydrogen sulfide, what will be happening? Say, reaction will remain same, but instead of oxygen, final product will release sulfur. Okay, so in that way, sulfur reducing bacteria prevailing thrives. So after that, again another oxygenation events happen. Okay, so we will be restricting our discussion in the sulfide rich oceans. Now you can note from 1.8 to 0.8, in this period most of the proterozoic basins sedimentation occurred, and that proterozoic basins are very much important because of mineral potential. Okay, so if we see the global temperature record also from Del Etido stable isotopic study, okay, oxygen and if we see even sulfur study, carbon study, okay, so those will be giving different type of ideas, different type of estimations. Now sea water temperature was around, during that boring billion, was around how much? 50 degree. See, 50 degree. This is to 1.8 around. So during boring billion, sea water temperature itself quite high, not like today. 50 degree means starting of hydrothermal, that is called epithermal condition. So freely available epithermal condition was thriving. It was common. Okay. So that in that high temperature condition, what happens? Reaction rate will be more. Reaction rate will be always be more. Correct? So that is the implication. Any types of reaction were at higher rate. Now since that time bacteriochlorophyll, they were using H2S instead of H2O. So they were fixing glucose and releasing, by using CO2 they will be releasing sulfur. So oxygen levels during boring billions are thought to have been marked lower than during the great oxidation event, perhaps 0.1 to 10% of modern level. And there are two major supercontinent cycle happen, Columbia and Rodinia formation, and one breakdown, that is Greenville orogeny, and then Pan-African orogeny, of course. So the term boring billion, as I have mentioned, it was coined by Martin Brazier. He pointed out from 2 to 1 billion years. Afterwards, after careful investigation, more precise timing was 1.8 to 0.8 billion years. Okay, so now at the end, I also would like to state one more important thing that to come into context is euxenia. What is euxenia? As I have mentioned, there are certain periods when water, oceanic water, lake water, show very much lesser oxygen, that is oxygen depleted condition, and sulfide rich condition, that is H2S enhancement. So that is there are certain implications for that. Euxenic condition are characterized by dominating effects of sulfur reducing bacteria, high organic bioproductivity, restricted circulation, and so black cell types of deposition, intense reducing condition, and therefore economically or geologically uranium and certain metal, especially redox sensitive trace elemental metal like molybdenum, vanadium, uranium, rhenium, they were precipitated under reducing condition. From that point of view, proterozoic basins are very much important, especially for uranium. That is why Kadapa, Bhima, Badami, that means Kaladgi basins, even in parts of Vindhya, they are very much significant for these kinds of elements and uranium. And moreover, since these kinds of euxenic basins conditions were prevailing that time, So there are also likelihood of getting good potential of high organic matter, which in turn may be relevant for hydrocarbon source rocks. And moreover, Euxenia is a key indicator for paleoclimatic research study, especially mass extinction event, oceanic anoxic events. These can be studied, and Euxenia plays significant role in these aspects, in this context. So that's it. So this is a brief glimpse of boring billion. I hope you understood. Thank you.